All right, so this is Math 2, Lesson 313, and we will be talking about probability, different ways to organize things, different ways to figure out some complex probabilities. So we're in Google Classroom. If you want to follow along on the note guide, which you need to turn in your notes, so you can use the note guide that you can find in Google Classroom under Lesson 313 or a piece of lined paper. So let's go ahead and get started. We're going to be reviewing ideas of probability, such as systematic lists, tree diagrams, and area models to represent the elements of the sample space, account for outcomes that are not equally likely, and identify events. So systematic lists is pretty straightforward. Tree diagrams is one that we haven't spent time studying formally. I am going to use them. If they confuse you, there is a video that is optional for tree diagrams if you need more detail. You will find that certain tools may work better for particular situations. As you work with your team, keep in mind the following questions. What are the possible outcomes? Are the outcomes equally likely? Will a tree diagram, list, or area model help? What is the probability for the event? So the whole goal is to figure out probabilities, and the other things are all tools that help us figure out probabilities. All right, so let's list the outcomes in the sample space. Oh wait, suppose we have two coins that we flip the first one, then flip the second one. So we're flipping them separately, not simultaneously. So what could I have? Well, I could have both of them come up heads. I could have both of them come up tails. I could have the first one come up heads and the second one come up tails, or the second one come up tails and first one come up tails and the second one come up heads. These four are my only options. Okay, a tree diagram. The first one comes up heads. My second one can come up heads or tails. So you'll notice I have the head here, if I go across this line, and the head tails there. That's my two outcomes from that part of the tree. My first one can come up tails. If it comes up tails, I can have a head and a tails. And again, those are it's hard to see that there are four possibilities here. I love tree diagrams. I like them very, very much. I've got heads, tails, heads, tails. So all four of them are there. And then we're going to create an area model. So this is what we were doing in class, the area model. So we've got the chance that we get, so we've got heads, tails, because those are my two things, what they can do. As I multiply through, I've got heads, tails, head, tails. Because heads goes first. Heads, tails, heads, and tails. And so those are my other choices. Okay, so now I've created the three things. If you're having trouble with the sample space, the area model should help you get one of those, but the area model can, not always work. Area models are awesome when the choices are not equally likely. But all of our choices here are equally likely, so the area model can just help me create my sample space. The tree diagram can also help me create my sample space if you're having difficulties creating a sample space. What are the probabilities that when two coins are flipped, only one head will show up? So exactly one head, not at least one head. There's a difference. So if we look at our choices, which are all unfortunately on this page, so we kind of have to go back and forth, and you're lucky because it's all on your notes. Only having one head, that happened twice. Here and here, there were four choices, and that happened twice. So I have a total of four choices. Probability is always written. Number of possible outcomes goes on the bottom. In this case, 4. There are 4 choices of things that can happen when I flip two coins. And then the numerator is the number of outcomes I want, number of desired outcomes. In this case, one head, and there were 2 that had one head. And so my answer is 1/2. There's my probability. 1/2, 50%, 0.5. Those are my probabilities. I like just to leave it as 1/2. So that was I. What are the chances that when two coins are flipped, both coins are the same? So that would be heads and tails, tails. Both coins are the same. So both coins are the same. So my number of possible outcomes is still 4. My number of desired outcomes is 2. And so this one is also 1/2. I didn't want to change colors. Go ahead and put that in black though. Okay. And then last. So this is the word that goes with that one. And then last, what is the probability that when 2 coins are flipped, there are no heads? So looking at our sample space, the only one with no heads is this tails, tails. And so what is the probability that when 2 coins are flipped, there are no heads? My sample, possible outcomes, is still 4. The number of desired outcomes is no heads. Having no heads, there was only 1 that had no heads. Okay, so this does not need to be simplified, and my result is still 1/4. I'm just going to put it in black so we know the answer is 1/4. Now you can leave your answer as 2 out of 4, but when we ask what the probability is, 2 out of 4 is, 50% or 1/2 or 0.5. Those are the things we want to say. So this would be 25%, 0.25, or 1/4. Okay, so 50% was for the other two, 25%, 0.5 we could say, and 0.25. Probabilities are always less than or equal to 1 and greater than 0. There's no negative probability, and 0 means it cannot happen. Okay, so there we go. That's our probabilities. That's a pretty straightforward one, 2 coins. Suppose we have 3 coins now. We flip the first one, we flip the second one, and then we flip the third one. How does the sample space change? Well, we have more choices now. More is going to happen because we're flipping more coins. And so instead of 4 outcomes, there's going to be more. So we have all 3 come up heads. We have the first 2 come up heads, and the last one comes up tails. We have the first one comes up heads, the next one comes up tails, and the last one comes up heads. We have the first one comes up heads, the next one comes up tails, and the last one comes up tails. So those are the 4 choices for my first coin is heads. Then we have my first coin is tails. Well, then I could have 2 heads that follow it. I have tails, then I could have a tails and then a head. I have tails and then head and then tails. Sorry, I should have done that one first. I have tails, tails, heads, heads, tails, heads, tails, 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 heads, and I have tails, tails, tails. So there are 8 outcomes if I'm not mistaken. But the tree diagram usually helps me the most. So my choice is the first one comes up heads. Okay, then the next one can come up heads, or the next one can come up tails. Then my next one can come up heads, or my next one can come up tails. I can get heads and tails. So this is just focusing on the first coin coming up heads. So I have heads, 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 tails, heads, tails, heads, heads, tails, tails. So I did get all the right outcomes for that first one. Because those are the only things that can happen, is I have heads come up. Then that next thing can be heads or tails. So there's my split. The next thing can be heads or tails, or heads or tails. So those are my splits. So then I also have, my first one comes up tails. And then again, I have heads and tails. And again, I have heads and tails. And again, I have heads and tails. So my choices here are tails, tails, heads, heads, tails, heads, tails, 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 heads, or tails, tails, tails. So again, 8 outcomes. I hope you can see that. And again, you can maybe see why I like the tree diagrams. Can you create an area model? Why or why not? Since there are, I don't think so. I think the area models that we're going to use are always going to have 4 boxes, and this has to have 8 outcomes. And so it's a little trickier because I still only have heads and tails as my choices, right? But since I have more coins, it doesn't work to like add the extra coin on. So I don't think so. And if I'm mistaken, I'll let you know later. Okay, so then we're going to answer the same sort of questions as we did last time, but for all of mine, my number of possible outcomes, my denominator, is going to be 4. Okay, and then again, the numerator is number of desired outcome. What is the probability that when 3 coins are flipped, only one head will show? So there's one with one head right here, and one with one head right here, and one with one head right there. So there are 3. Oh, excuse me, my denominator is not 4. My denominator is 8. So there are 3. So the answer is, my numerator is 3/8. So it's 3/8, which is, using a calculator in case you're wondering, which is 37.5% or 0.375. So that fractions, decimals, percents work he did in middle school, it pays off right here. Okay. What is the probability that when 3 coins are flipped, all coins are the same? Okay, so all coins are the same. We're going to go ahead and mark that one not in green but in orange. All coins are the same. Heads, 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 and tails, tails, tails. So it's going to be 2 out of, my denominator is still 8, which is 1/4. Which is equal to 0.25 or 25%. Okay. What is the possibility that there are no heads at all? No heads at all. Just this great neon pink is that. All the rest of them have a head. So there's only one with no heads. So that's 1/8. 1/8. Come on. Which simplifies to nothing, but it's 0.125, which is 12.5%. Okay, and there you go. That's it. It's not too bad. Okay, 4 coins gets, of course, more complicated, and we add some more choices and so on. And so these can get complex. Again, that's where the tree guide, for me, the tree diagram helps me make sure my sample space is right. That's why I like it. I like area models when things are not equally likely. These are all equally likely. Heads and tails, assuming your coin is fair, these are all likely. They're all equal. Rimshot McGee has a 70% free throw average. The opposing team is ahead by 1 point. Rimshot is at the foul line with just a few seconds left in the game. Take a point. What do you think is the most likely outcome for Rimshot? 0 points, 1 point, or 2 points? Again, he's at the free throw line. He is going to take 2 shots. For those of you who don't understand basketball, each shot is worth 1 point when you're at the free throw line. So you get 1 shot and then you take the second shot. So what's the probability? What do you think is the most likely? No points, 1 point, or 2 points? So just decide. You pick, because I'm not going to decide. I have too much knowledge. So make a decision. Thanks. All right. So now we're going to make a systematic list to represent the outcomes. So he makes the first shot, which we're going to do makes and misses. So makes is 1 and misses 0. Let's do that. Makes is a 1 point and misses 0. So he makes both shots. So he gets 2 points. He makes 1 and first one misses the second one. He misses the first one and makes the second one. He misses them both. Okay? Draw a tree diagram to represent this choice. So he has, again, two choices to start. He makes or he misses. If he makes, he can either make or miss. If he misses, he can either make or miss. What happens the first time does not affect what happens the second time. Sometimes a little bit it doesn't affect the probability, but nerves and, oh no, I've missed it now, what's going to happen? Oh no, we're going to have to go to overtime, and then there's all this pressure, and it changes how we do things. A lot of athletes, you'll notice, go through the same routine. One of my favorite basketball players, he retired in the 90s, so you probably have no idea who he is Hornacek. I can't remember his first name. Greg. He coaches now, and I don't remember where. But anyway, he had this thing that he would do at the free throw line where he would wipe his face, and he would do all these things, and he was like a 90, I think lifetime was 92% free throw shooter. He was money for us on the line. Loved it when he played. He played for the Utah Jazz, which is my team. Anyway, really important story. But he would always do these things so that the pressure of the situation didn't change what was going to happen. He just centered himself. He did these things. The rubbing on his face was to say hi to his kids. And so it was this thing that he did every single time, and it helped. So, there we go. All right. So, draw an area model to represent the situation. So there we are. So either he makes or he misses, right? So he makes or he misses, makes or misses. And I forgot, we're supposed to be doing probabilities, not just numbers. But anyway, 1, 1, 1, 0, 1, 0, 0, 1, and 0, 0. So let's go back. Each of these is equally likely. So this is 1/2 and 1/2 and 1/2 and 1/2. So this is 1/4. This is 1/4. This is 1/4. And this is 1/4. And so if we're looking at our sample space, there's a 1/4 chance this will happen. There's a 1/4 chance this will happen, a 1/4 chance this will happen, and a 1/4 chance this will happen. So the chances of him making 2 points is the most likely because that's 1/2. 1 point, that's 1/2. 2 points is only 1/4. 0 points is 1/4. Okay, now he has 70% probability. So that changes things. So this is just if it was just like flipping a coin, but this isn't just like flipping a coin. So that changes this. Okay, so let's erase these numbers because those are if everything was 50-50, but it's not for rim shot. For rim shot, it's 70-30. He's got a 70% chance he'll make the shot and a 30% chance he will miss the shot because he's a good free throw shooter and that's his average. So 70, so that's 7/10, and miss 30 or 3/10. So because they are not equally likely for rim shot. For me, they're equally likely. Actually, I'm much more likely to miss. I'll be completely frank. I'm not a very good free throw shooter, especially since I haven't tried it in years. So I'm really bad now, but that's not how better. So I'm most likely to get 0. But let's see what's going to happen. So since it's 70 times 70, so kind of when we fill in this out, when we're filling out, it's 7 times 7, which is 49 over 100. So this is 49%. This is 3 times 7, which is 21, again over 100. So 21%. This is 21%. Same multiplication. And then 3 times 3 is 9 over 100. And since it's 9%, and then these should add up to 100. So 49 plus 21 plus 21 plus 9 should add up to 100. So anyway, going back to this says it has a 49% chance of happening. This has a 21% chance of happening, 21% here, and 9% here based on the way rim shot shoots, instead of based on what's true for everybody. So if what's true for everybody, he's more likely to make 1 point. But for rim shot, making 1 point is 42%. So he is actually more likely to make 2. See the difference there? Does that make sense? Okay. So rim shot is more likely to make both. He is. but only just, not 50%, 49. So again, 49 plus 9 plus 42 has to make 100, which it does. So we're all set. We got this right. That's where the rounding can come in problems. So that's why they're out of 10, which works for percentages. Use any representation you can to help you calculate the probabilities. I'm going to put, I think for this one, since it's not equally likely, I'm going to put my diagram down here, my area model. So 7/10, and again, this is makes a point, 7/10, misses a point, 3/10, misses a point, 3/10. So 7 times 7 is 49 over 100, so 49%. Let's use a different color in there, just for contrast, if nothing else. 49%. 3 times 7 is 21 over 100, 21%. 21%. 3 times 3 is 9 over 100 is 9%. Okay, so what is the probability he will make both free throws and win the game? 49%. What is the probability that he will miss both free throws and lose the game? 9%. What is the probability that the game will end in a tie? 42%, which came from 21 plus 21. Okay? Again, way helpful for figuring that out. Whereas the tree diagram wouldn't be helpful. Because the tree diagram, again, and this is the sample space by itself, assumes 50-50 for each option. But for rim shot, 50-50 is incorrect. For me, for somebody else, for Shaquille O'Neal, he was about 50%. Okay, so different people's practice levels, all those things come into play. So when unlike flipping a coin, which it is 50-50, if the coin is fair. Okay, and that's all. Hope you had a great time. Hope this helps you understand a little bit more about probabilities. And again, area models, the most helpful when it's not equal. With 50-50, when things are equal, all of them work. But when things are not equal, love the area model. Love the area model. Okay. All right. Have a great day.